Planet Earth 2023. Welcome to a society on the verge of an ecological disaster. In Western society, there is a widespread agreement on the necessity of an energy shift towards renewable energies, driven by the imminent ecological tipping points that emphasize the need for urgency. Thankfully, the required technologies have been at our disposal for decades, and solar, wind, and hydroelectric energy sources are illuminating the way to a sustainable tomorrow. The backside of renewable energy is its fluctuating nature. It makes it very difficult to align the supply and demand of a power grid in a controlled manner. With fossil fuel power generation, maintaining stability used to be a game with few variables, most of which could be controlled. With more and more of the power supply coming from decentralized, fluctuating sources, maintaining the balance is a huge challenge. Architects and engineers are now confronted with this challenge and are working on designing efficient ways to store energy cleanly. In the event of insufficient storage, a prolonged period of low energy supply could leave us in darkness. Depending on the topographical characteristics of a region, pumped hydroelectric power plants are currently the most viable option for energy storage. During periods of power overproduction, water is electrically pumped up to the higher reservoir, effectively storing electricity as potential energy. If the demand exceeds production during periods of energy scarcity, water flows through a turbine connected to a generator, returning electricity to the grid. In order to be able to apply this storage method in regions without differences in altitude, the balancing architecture is being developed. These buildings are conceived as floating structures with a water tank in the lower part of the building. When there is an energy surplus, the water is pumped out of the tank, and the overall lighter structure rises out of the water. When energy is needed, the hollow structure lowers again, letting water flow in through a turbine, releasing electricity to the grid. Certainly, the stored energy in this system is inherently less than that of a traditional power plant. The quantity diminishes proportionally with the mass of the water and the disparity in altitude. While this technology may not offer a solution to all energy storage challenges, it presents a compelling option for isolated floating structures that operate independently from the grid. It also becomes particularly relevant in scenarios where land scarcity necessitates construction on water. In this project, the upward and downward movement is regarded as an opportunity for a performative moment, and this aspect is underscored in both its architecture and functionality.